Okay, for our last topic that we're going to do in this course on statistics, we're going to talk about lines of better fit and best fit, two things. First, let's talk about some scatter plots. Here are 4 different scatter plots. Well, actually 5, including that one. The interesting thing about scatter plots is that for some of them, and 1 second, technical difficulty. Okay, sorry about that. Scatter plots are interesting. We've got 5 pictured here, and a couple of them you can actually see are linear. For instance, in this particular scatter plot, here's all your data. And we can tell as you increase on the x-axis, you also increase on the y-axis, a positive correlation. Here, this is sales with regards to temperature. As temperature increases, sales go up, and you can see the data indicating that. Wouldn't it be wonderful if you could find a line, the equation of a line, that would correspond to that data? Once you have that equation, then you can answer all kinds of questions, make sort of predictions as to what the sales would be at another temperature here, so on and so on and so on. So that's what we're going to be trying to do today, find what is called the regression line, or the line that would indicate as the best or better fit to the data. Now, granted, there's all kinds of data where there is no line of regression. Okay, here are 3 examples. There's just no correlation like we did in our last time together when I asked you, what about positive or negative correlation between height and color of hair, right? I mean, there's no correlation at all. And here are 3 exactly the same in which there is no correlation. All right, so I've got data here. I've got the points plotted. Here are your 4 data items, okay? So we have 1 and 2. We have 2 and up 3. We have 3 and up 2. We have 4 and up 3. And we have 5 and up 6, okay? Yeah, now what I want to do is I've given you 2 lines, y equals x. Here, this is the one that's y equals x. And the other one, y equals 2/3 x plus 1 1/3, is this one. And my question would be, which of those 2 lines do you think would be the line of better fit? Okay, they both have advantages. This one, to be honest with you, the first one, y equals x, kind of looks pretty good. It goes shooting up right through the middle of them and might be a good one. This one actually hits one of them, which might give some credence to that being a good one. All right, so exactly how do you do this? You have to make a chart for each equation, okay? So let's do the first one. Y equals x. We're going to make a chart, and the chart has headings of x, y, y hat, e, and e squared. It kind of looks like the chart we made for standard deviation when we did error and error squared, okay? So my x and y's are just as they are given there in the data. So I have 1 and 2. I have 2 and 3, 3 and 2, 4 and 3, 5 and 6. And now we've got to find y hat so that we can compare it to y. The y hat comes from taking the x value and putting it into the equation. Well, putting the x values into this equation is really easy in this one because it simply gives you what the x value is, y equals x. So the y hat is going to be 1, 2, 3, 4, and 5. Okay? Now, how about the error? Okay, we want to get the line that has the least amount of error, that is closest to the data. So we have to find the error. Between 2 and 1 is 1, squared is 1. Between 3 and 2 is 1, squared is 1. Between 2 and 3 is -1, but when you square, you get positive anyway. So I'm just going to say it's 1, squared is 1. 3 and 4 is 1, squared is 1, 6 and 5 is 1, squared is 1. Add this up, and I get 10. Sorry. I get 5. Okay? So the error squared in that particular problem is 5. All right? Now, we have the same data. Let's now do the other line. And the other line is the y equals 2/3 x plus 1 1/3. Okay, so let's find y hat. I have to put the x value down here. Okay, so putting 1 in here makes 2/3 times 1 is 2/3 plus 1 1/3 is 2. Putting 2 in here, 2 times 2/3 is 4/3, or 1 1/3 plus 1 1/3 is 2 2/3. Putting 3 in, 3 times that is just 2 plus 1 1/3 is 3 1/3. Putting 4 in, 4 times 2/3 is 8/3, which is 2 2/3 plus 1 1/3 is 4. Let me go over that again. 4 times 2 is 8/3. 3 into 8 is 2 2/3 plus 1 1/3 is 4. Yeah. Putting 5 in. 5 times 2/3 is 10/3, which is 3 1/3 plus 1 1/3 is 4 2/3. Okay? Now, to find the error, we're going to have to subtract the y values. Okay? Most of these I can probably subtract in my head. It's the squaring that's going to get a little interesting. So here there is 0 error. Here there's 1/3 for an error. Here is 1 1/3 for the error. Here is 1. And when you subtract these two, you get 1 1/3 for the error. Okay, 0 squared is 0. 1/3. Try that again. And I get 0.11. For 1 1/3 squared, I get 1.78. For 1 squared is 1. 1 1/3 is 1.78. 1 1/3 is 1.78. Okay? Add those all up, and I get, wait a second. What did I do? I have an extra one here. Sorry. I was looking at that. Okay, so we've got to add those all up. So I have 1.78 twice plus 1 plus 0.11. And I get, do that again, 1.78 twice plus 0.11 plus 1, and I get 4.67. So for this equation, 4.67 is the error. For that one, it is 5. Which one is better? This one is better because it has lower area. Lower error. Boy, pardon me. All right. Now, what about the line of best fit? Okay, the line of best fit. So these were 2 lines. These 2 lines that we did, we picked out this one as the line of better fit. But now if we go back to that data, okay, surely we can come up with a line that might be even better than these 2, have a lower error than that, okay? So there is a way to find the absolute line of best fit. It is very, very interesting with a very, very complicated formula, all right? You will not have to know these formulas. They'll be on the test. Even when we did this first one, the line of better fit, I will give you the column headings. You just need to know how to do it, okay? So here are the formulas to get the slope. Remember, the author calls B1 the slope, and B0 is the y-intercept, okay? Here is the formulas, the way you get it. To get these numbers, you've got to set up a chart with headings of x, y, and x squared. So let's do that. So set up a chart. We're going to have x, y, and x squared. Okay? All right, so let's do that. Put your data in the X and Y columns. And the data, once again, let's go back and get the data. The data was 1 and 2, 2 and 3, 3 and 2, 4 and 3, 5 and 6. Okay? There's your data. All right. And now let's go back. Let's complete the chart. This is simply X times Y, so multiply 2, 6, 6, 12, and 30. Okay? This is the square of the X column, so just square them. 1, 4, 9, 16, and 25. Okay? When finished, total each column to get the summation. Okay? And the total number of data is n, so there's 5, so we know that n is equal to 5. So let's add these up. 9, 12, 15 for this one. Add these up. 9, 11, 16 for this one, I think. Add these. 42 and 8 makes 50, 56. Double check that. 42 and 6 is 48 and 8 is 56. Add these. That would be 41, 55. Okay? 55. Double check it. 13, 14, 30. Yeah, 55. Okay, now we have to work out the formulas here. And let's see if we can do that. The summation, to get the slope first, the summation of the XY column, okay, is 56. So where can I do that? Let's do 56 here, okay? Minus the summation of the x's times the summation of the y's, okay? So the summation of the x's times the summation of the y's is 15 times 16, which I ought to know that in my head, but I don't. 15 times 16 is 240 right here. So it's minus 240. Okay, over n, and over n is 5, so it's like 5, and then divided by this whole mess, so divided by the whole thing, the summation of the x squared is 55, minus the summation of the x's squared. This is different from this, okay? This is the summation of the x's. 15 squared is 225 over n again 5. Okay? 240 divided by 5 is 48. 56 minus 48 is 8. 225 divided by 5 is 40, 45. 55 minus 45 is 10. The slope is 0.8 or 0.8. Okay? Now we have to do the y-intercept, where it's going to hit the y-axis. So I'll just do it in that white area over there. The summation of the y's is 16 minus b1, which is your slope, 0.8. Okay? Times the summation of the x's is times 15. And then it's all divided by n, which is 5. So 0.8 times 15 is 12, I think. Yep, 16 minus 12 is 4. This is 4/5. Okay, so I have 4/5 for the y-intercept. Okay, so I have the slope and the y-intercept. I can write the equation, y equals mx plus b, and the equation for the line of best fit would be the slope, 0.8, x plus the b value, 4/5, which is 0.8x plus 0.8. That is the absolute line of best fit. You cannot find any that is better than that. It would be a line that hits at 4/5, right about here, and the slope would be up 4 and over 5 and it would go right up through. It actually would probably split right through the middle of those two to give you the absolute line of best fit, okay? Let me clear that a bit, and I've got another example I want to go through with you. Okay, now, line of better and best fit. Once again, I have 4 items of data here. Let me point them out to you. Here is 1, 0, 2, negative 1 here, so here are 2, 3, 4, over 3 and up 4, and over 4 and up 5. Okay, those are the data items. There, there, and there. I put some other points and markings in here just so we could see what the equations of the lines are. There are 3 lines shown in the coordinate plane. Determine which of these 3 would be the line of best fit. So we have got to first find the equation of all 3 lines. All right, this line, you can see this blue line here, has a slope of up 2 and over 1. So the slope is 2, and it hits the y-axis at negative 2. So I have y equals 2x minus 2. There is one of them. Second line would be this line right here, coming right up through the middle like this. I can see the slope is up 3 and over 1. I'm not exactly sure where it hits the y-axis. So if it's up 3 and over y equals 3x, I could put a point in that's on this line. How about 1, negative 2? So if I put 1 here and negative 2 here, subtracting 3, that gives me a minus 5. It's going to hit it. That kind of looks like it does hit it, minus 5. Okay? And the third line is this line right here. Okay? I know it is up 5 and over 1 for the slope. So it's going to start off y equals 5x. And let's, again, put a point in to find out where it's going to hit the y-axis here. How about the point 2, negative 1? If I put 2 and negative 1 here, I get negative 11. Okay? Now, I must do a chart for each one of these lines to find the line of better fit. And if you remember, the headings here were x, y, y hat, error, and error squared. Okay, we'll do one for each line. All right, my data points again are 1 and 0, 2 and negative 1, 3 and 4, and 4 and 5. Okay? Y hat, I must put these up. I'm going to do this equation first. So you put 1 in for x, 2 minus 2 is 0. You put 2 in for x, 4 minus 2 is 2. You put 3 in for x, 6 minus 2 is 4. Put 4 in for x, 8 minus 2 is 6. Find your amount of error is 0. Difference between those two is 3, 0, 1. Square them all, 0, 9, 0, 1. The error in this line squared is 10. Okay? Everybody with me on that one? Okay, so let's do the next one. Next line, put 1 in for x, 6 minus 5 is, put 1 in for x, 3 minus 5 is negative 2. Put 2 in for x is 6 minus 5, or 1. 3 in for x, 9 minus 5, or 4. 4 in for x is 7. Error, it's going to be 2, 2, 0, 2, squared, 4, 4, 0, 4. I get an error for this one of 12. Okay? Hopefully I did that right. 3 minus 5 is negative 2. 2, 6 minus 5 is 1. 3, 5 is 4. 4, 12 minus 5 is 7. And error, 2 squared 4, 0, 2 squared 4, 2 squared 4. Looks good. Okay. One more to go. Okay, y hat, put 1 in. 5 minus 11, that's negative 6. 10 minus 11, negative 1. 15 minus 11, 4. 20 minus 11, 9. Error, 6. 36. Error, 0. 0. Error, 0. 0. 4. 16. Error for this one, 42. This would be the line of better fit. Okay? It's not necessarily the line of best fit. It's the line of better fit. Out of the 3 blue lines we have there, this very first one is the line of better fit. Okay? The line of best fit would be a line that's probably not even there. And we're going to be able to figure that out. Okay, so let's go back to the line of better fit. And all we need for that is the data. Okay. And we're going to do x, y, and x squared. The data, once again, 1 and 0. 2 and negative 1, 3 and 4, and 4 and 5. Okay? So, the line of better fit, or best fit, pardon me, let's get rid of this. Okay, and now we want to do multiply to get your x, y's here. This is 0, negative 2, this is 12 and 20. Square your x's are 1, 4, 9, and 16. Now get the totals. Okay? The x's add up to 10. The y's add up to 8. The xy's add up to 30. And the x squareds add up to 30. That's odd. 30 and 30. But I think it's right. Okay, let's go back and get the formula. All right, for the line of absolute best fit, let's do the slope first. The summation of the xy's is 30. So we have 30 and minus the summation of the x's times the summation of the y's is 80 divided by 5 over the summation of the x squared column is 30 minus the summation of the x's squared. So 10 squared is 100 divided by, and I said 5, I'm being an idiot. There's only 4. Sorry. 4 and 4 gives me 10 on the top, 5 on the bottom. Slope is 2. Okay? Now let's do the y-intercept. The summation of the y's is 8 minus the slope 2 times the summation of the x's 10. And it's all divided by 4, darn it, not 5. So 8 minus 20 is negative 12, divided by 4 is negative 3. Okay? The line of absolute best fit, 2x minus 3. If you want to look at the picture, once again, the picture is here. Why does that keep doing that for me? Okay. The line of best fit hits at negative 3. It has a slope of 2. It's coming right up through like that. Is the absolute line of best fit. And this will conclude all the new material that you are responsible for this class. Your homework, I put a couple of extra problems in there as far as problems we've done in the past, just for a bit of review. And your book problems, you can see those are down at problem 4. All right? Don't forget the extra problems when you're doing your homework.